The frictional force acting on a small block of mass 0.15 kilograms, while it is moving on a horizontal surface, has magnitude 0.12 Newton. So the friction is 0.12 Newton. The mass of this block is 0.15 kilograms. The block is set in motion from a point X on the surface. You can see that in the diagram with speed 3 meters per second. It hits a vertical wall at a point Y on the surface 2 seconds later. So it takes 2 seconds for this particle to go from X to Y. The block rebounds from the wall and moves directly towards X before coming to rest at the point Z. So it goes from X to Y, and then on its way back, it just comes to rest at the point Z. At the instant that the block hits the wall, it loses 0.072 joules of its kinetic energy. So when it hits the wall, it loses 0.072 joules of kinetic energy. The velocity of the block in the direction from X to Y is V meters per second at time t seconds after it leaves X. So basically, what they're saying is in direction from X to Y, the velocity is V. That means this is the direction that we're going to be taking positive from X to Y. All right, this is the positive direction. Find the values of V, find the value of velocity when the block arrives at Y and when it leaves Y. So when it arrives at Y and then when it leaves Y. And find also the value of T when the block comes to rest at the point Z. And once you have done all of that, they want you to sketch the velocity time graph for the journey of this particle, of this block as well. Now let's do it step by step. So there are quite a few things that they're asking us for. Values of V when the block arrives at Y and when it leaves Y. So first of all, we are considering this part of the motion from X to Y. So let's see what happens from X to Y when the block goes from X to Y. What do we know about this part of the motion? We know that the initial velocity from X to Y, that was 3 meters per second. So that's one piece of information that we have. Initial velocity is 3. And we know the time taken. It told us that it takes 2 seconds to hit the wall. So the time taken is 2 seconds. What else do we know? The frictional force is 0.12 Newton. Let's think about the kinematics quantities that we do not know. Final velocity, well, that's what we have to find out basically. V is what we are looking for, the velocity at which the block hits the wall. Displacement, do we know the displacement? No, displacement is not given. Acceleration, no. Displacement and acceleration are not known. We have to find the value of V. Now we can't find that because we don't have enough information for that. We only have initial velocity and time. So now we need to think about how we can figure out any of the remaining pieces of information from the other information that we're given. We are given that the friction is 0.12. And there's no other force. You can see there's no other force acting on the block as such. They haven't really told us about any other force acting in the direction of motion. So there's only friction. Friction is 0.12 Newton. There's going to be weight of the object, but that acts downwards. It does not have any impact on the motion of the object as such. Weight is 1.5 Newton. Now we already know the value of friction. So we don't really have to use weight or reaction as such. Reaction will also be 1.5 Newton in this case, but that's not required. Along the surface, there's no other force acting. So what we can do is we can find the acceleration value. How do you do that? Resultant force equals mass into acceleration. If the right side is the forward direction, what's the forward force? There's no forward force. What's the backward force? The backward force is 0.12. Minus 0.12 equals mass, which is 0.15 into acceleration. What we can do is we can find the value of acceleration from this. minus 0.12 divided by 0.15, and that's giving me 0.8. 0.8 meters per second squared, negative 0.8 meters per second squared. That's the acceleration of the block. That means it's deceleration. Its value is decreasing. The velocity value is decreasing. So we know that acceleration now is minus 0.8. Now, using these pieces of information, can we find the final velocity? We can say v equals u plus a times t. So v equals 3 minus 0.8 multiplied by 2, and that gives us 1.4 meters per second. This is the velocity at which the block arrives at y, at which it hits the wall. Okay, this is the velocity of arrival at y. Velocity when the block arrives at y. That's the first thing that we were looking for. And then it says, find the velocity when it leaves y. Now the block hits the wall, right? And because of that, since there's going to be a collision, it's losing some energy. They're saying it's losing 0.072 joules of kinetic energy. Okay. Now that might be converted to some other type of energy that we're not considering. It could be thermal energy, it could be sound energy, right? Any other energy. So it converts to that. So we're losing some energy. That's 0.072 joules of kinetic energy. There's a loss of kinetic energy. Can we find the speed at which the block is now going to leave y? We can find the kinetic energy of arrival. So corresponding to this velocity, what's the kinetic energy? Half mv squared, half into 0.15 into v squared, that's 1.4 squared. Let's see what the kinetic energy was when the block arrived at y. 0.15 divided by 2 into 1.4 squared, and that is giving me 0.147 joules. This is the kinetic energy when it arrives at y. It loses 0.072 of its energy. So what's the kinetic energy when leaving y? Initial kinetic energy was 0.147, and it loses 0.072 from that. And that gives us 0.075. 0.075 joules. This is the kinetic energy when the block leaves y. Okay. Now, can we find the corresponding velocity for this? Now we have the kinetic energy. We can find the corresponding velocity for this. We can say 0.075, that equals half mv squared, half into m is 0.15 into v squared. Let's see what that gives us. 0.075 multiplied by 2 divided by 0.15, square root of that, that's just 1. This is turning out to be 1 meters per second. Okay, but remember, we were considering the right side positive. It says v is the velocity of the block in the direction from x to y. So it's the velocity in the right direction. That's what v represents. Now, when it leaves y, it's actually going towards the left side. So its velocity is supposed to be -1. So we say the value of v here, it has to be -1. So it's -1 meters per second. This is the velocity when the block leaves y. Is that okay? Any problem until this point? Make sense? We know the velocity of arrival and the velocity of leaving. So it arrived at 1.4 meters per second and it left at 1 meter per second. Okay, good. Now we need to find the value of t when the block comes to rest at z. Now what's t? T is the time after it leaves x. So what's the total time taken from the instant when it starts moving from x and until it reaches the point z? Now we already know the time taken from x to y. We were already given that. From x to y it took 2 seconds. Now what about the journey from y to z? Let's consider that part of the journey now. From y to z. Okay, now what's happening from y to z? Remember, we're considering the right side positive. So for that, for one object, we said we should remain consistent throughout. We're considering right side positive. Now, when it goes from y to z, it's going to the left side actually. It's going like this, y to z. Now, what do we know about the journey from y to z? What's the initial velocity now from y to z? Well, the final velocity in the previous part was, now it's the initial velocity. So we say initial velocity is going to be -1. Why -1? Because we're considering right side positive. Okay, initial velocity is -1. What about acceleration? What should be the value of acceleration? In fact, let me just write down the final velocity here as well. The final velocity is going to be 0 because at z it comes to rest, right? So these are two things that are easy to figure out. So I'm going to write them first. This is 1.4 meters per second. On its way back, it's -1 meters per second. At z, it's 0 meters per second. So we know the initial velocity from y to z, that's -1. We know the final velocity, that's 0. What about acceleration? What's the value of acceleration in this case? Any idea about this? What's the value of acceleration? It's the same surface and the same block. So the friction between the two surfaces is going to remain the same. There's no other force acting apart from friction. So the friction that was acting from x to y, that's the same friction that's acting from y to z. When it's moving from y to z, friction is now going to act in the right direction. Now the value of acceleration that we found earlier was -0.8. From y to z, since friction is acting to the right side, and that's the direction that we're taking positive as well, the acceleration value is now just going to be positive. We say acceleration value is equal to 0.8 now. And you can think of it like this as well. Since the initial velocity was -1, it's going from -1 to 0. The velocity is increasing, so acceleration is 0.8. It's going from negative to 0. So we say it's plus 0.8. You could also take this positive direction. In that case, you would say initial velocity is 1, final velocity is 0, and acceleration is -0.8. That would also be a perfectly valid way of doing this. But you just need to make sure that you understand then that in the previous case, you were considering the right side positive. That's why this velocity was -1. Now, if you take left positive, then this could be taken as 1. And you could use these values as well. And that's also fine. Okay, so you could do any of these two, and now you can find the time taken from y to z. You've got v, u, and a. All you have to do is find the value of time. How can you do that? T. What's that? V equals u plus a times t. V0 minus 1 plus 0.8 times t. The value of t turns out to be 1 over 0.8, so I think 1.25. Yeah, 1.25 seconds. So what's the total time taken? from x to z, 2 seconds had already passed from x to y. And then from y to z, it takes 1.25 seconds more. And that gives us 3.25. That's the value of t when the block arrives at the point z. Is that okay? That's the next thing that we were looking for. This is the value of t when the block comes to rest at z. And now that we know this as well, we need to sketch the velocity time graph for this whole journey. So how do you draw the velocity time graph? Remember, we're considering the right side positives for this velocity time graph. That's what they've told us in the question. X to y is positive direction, from left to right. Right side is positive. Let's draw the velocity time graph for this journey now and see how that's going to look like. So we have this x and y axis like this. Velocity on the vertical axis, time on the horizontal axis. What are the important time intervals, time instances? Starts from 0, and then after 2 seconds, it hits that point y, and then at 3.25 seconds, it basically comes to rest at the point z. Let's mark the important points. At t equals 0, what's the velocity? It's 3 meters per second. So initial velocity was 3 meters per second. And then it went to 1.4, and then -1, and then 0. Let's mark these points. At 0, the value for velocity is 3. So let's say we've got 3 here. Okay, so we've got 3 here. And when t equals 0, the value of velocity is 3. This is one point that we've got. At time t equals 2, the value of velocity is 1.4. So it has to come somewhere around here. Let's say this is 1.4. And then when the value of velocity, when it hits the wall, what happens is its velocity instantaneously goes from 1.4 meters per second to -1 meters per second. So at that same time instant, what happens is the velocity changes abruptly to -1. So it's going to go down here like this. And then at 3.25, it comes to rest. Now, throughout the journey, remember the acceleration was constant. While it was going from x to y, there was only friction acting. That was a constant force. So the acceleration was constant. That was -0.8. And then it's on its way back as well, there was only friction acting. So acceleration was constant in that part as well. So how is the graph going to look like? It's going to be straight lines because acceleration is constant. The gradient of a velocity time graph represents acceleration. That means the gradient is constant. If gradient is constant, it's a straight line. So you just have to draw these straight lines like this from 3 to 1.4. And then it goes abruptly to -1 here. This is -1. And then it goes back to 0 from this. This is what the velocity time graph for this journey would look like. Is this all right?
Yes, sir.
Okay. So that's the velocity time graph. That's the first part. That was a 9-mark question. So required quite some thinking. Now it says the displacement of the block from x in the direction from x to y is s meters. Sketch the displacement time graph. Show on your graph the values of s and t when the block is at y and when it comes to rest at z. So now we need the displacement time graph. Now we don't have any displacement. We do not know the displacement from x to y or from y to z. Let's find the values of these displacements. Part 2. So what happens from x to y? What information do we have? Remember, we're considering the right side positive. Initial velocity was 3. Final velocity we found was 1.4. Time taken was 2. And we also knew acceleration, that was negative 0.8. So you can use any of the formulas that you know from constant acceleration formulas, ut plus half at square, for instance. Just input values. There are 3 into 2 plus half into a, which is negative 0.8 into t squared. That's 2 squared. And that will give you the value of displacement from x to y. That's 6 minus 0.4 into 4, and that's giving me 4.4 meters. So from x to y, it takes 4.4 meters. It's 4.4 meters in total. Now, what about y to z? Now it's coming back from y to z. Let's consider that part of the journey now. Again, we're considering right side to be positive to stay consistent throughout for this object. What was the initial velocity? Initial velocity was -1. The final velocity was 0. The time taken was 1.25. We found this as well. Yeah, 1.25. And acceleration was 0.8. Again, we can use any of the formulas that we know about. We could use s equals ut plus half at squared again here. And that gives us -1 into 1.25 plus half into a, which is 0.8, into 1.25 squared. And that's going to give you the value of this displacement as well. Minus 1.25 plus 0.4 into 1.25 squared. And that's giving me minus 0.625. You could use any of the other formulas as well. You could use s equals u plus v over 2 multiplied by t. You could use 2as equals v square minus u square. Any of the other formulas could also work, and that's perfectly okay. This is the result that we get from this, minus 0.625. So now that we know the displacements, now we can try to sketch the graph and see what that looks like. Again, these are the important time instances, t equals 2 and t equals 4, or t equals 3.25. Now what I'm actually going to do is I'm going to keep this graph in front of me, and that will help us understand how the displacement time graph is going to look like. Let's mark the important points first of all. Okay, so now we have displacement time graph. At times t equals 0, what's the displacement from x? Remember, we are measuring displacement from x. So at time 0, displacement is also 0 because the object is at the point x. Let's start from 0 displacement. Okay. What about time 2? At time t equals 2, we are given that the displacement is 4.4. From x to y, the total distance is 4.4. So in the first 2 seconds, it travels 4.4 meters. Let's say 4.4 is somewhere here. This is 2. This is 4. So 4.4 maybe somewhere around here. So from 0, it has to go to this point. And then at 3.25, what happens? From y to z, the displacement is negative 0.625. So basically, what we understand from that is this whole distance is 4.4, and from y to z, it's 0.625. So what's the displacement of the object from x at z? 4.4 minus 0.625. So the final displacement is 3.775. So at time 3.25, the displacement value is 3.775. That may be somewhere around here. This is the final displacement. These are the important points that we have. It starts from 0, then it goes here, and then it goes here. Now, how does the graph look like? What is the graph going to look like? What's the shape of this graph going to look like? Okay. So what does the shape of this graph look like? How do we draw that? Any idea? Do we draw straight lines like this and this? Or do we do something else?
Sir, it's going to be curves.
It's going to be curves. Y curve.
Because displacement can't instantaneously change.
Right. Even with the curve, it would be changing instantly, no? If it's going like this, for instance, or even the other way around. As in, it's increasing gradually in either case, actually. With a curve as well, and also with a straight line, it is increasing gradually. As in, it will gradually go from this point to this point. So it's gradual in both cases. How do you understand the shape of the graph? You see, gradient of a displacement time graph gives you velocity. Gradient of a displacement time graph gives you velocity. What's the velocity at time 0? Velocity at time 0 is 3. What's the velocity at time 2? The velocity at time 2 is 1.4. The velocity is decreasing from a positive value to another positive value. It's decreasing from 3 to 1.4. That means the gradient of the displacement time graph is going to decrease from 3 to 1.4. So it's going to start from a higher positive value and then gradually decrease like this. It's not going to become 0 at the end because the velocity here is still 1.4. So it's not going to be flat at the end. It's not going to be like this because that means the gradient is 0 at the end. It's going to be something like this. Its gradient is going to be positive, more positive, and then it slightly reduces like this. This is what the graph looks like from 0 to 2. Okay? And then what happens afterwards? Its velocity is -1, and then from -1, it goes to 0. Now, it's not going to continue like this. You see, the gradient is going to be negative, and then from negative, it goes to 0. So close to this point, the curve is going to be flat, and here it's going to be negative. So the graph in the second part is going to look something like this. It's going to be negative value, and then go towards 0 like this. This is what the second part of the graph looks like. At this point, 3.25, the graph is going to be like this, kind of flat, where the gradient is 0. And it starts from a negative gradient. First, at this point, there's going to be a corner like this. This is what the graph looks like. This is the displacement time graph. Does this make sense? Okay. How can you figure out whether to draw straight lines or curves? In the previous case, you see, in velocity time graph, acceleration was constant. Acceleration was constant. So basically, you have to think about the gradient of the graph. If the gradient is constant, it's straight lines. the gradient of velocity time graph is acceleration. So for a velocity time graph, the gradient is acceleration. And acceleration in this case was constant. If the gradient is constant, that means it's a straight line because straight lines have constant gradient. In a displacement time graph, the gradient represents velocity. Gradient represents velocity. Velocity, you can see, is not constant. It's going from 3 to 1.4, then to 1, -1, and then to 0. The velocity is not constant. It's changing. It's changing here. It's changing in this part. Since the velocity is variable, the gradient is changing. So it has to be a curve. For a curve, the gradient changes at every single point. So it's a curve like this. Make sense? Okay. All right. Now, let me know if there are any other questions from the past papers that you're talking about. We'll do one more quickly. This was a long one. Okay, so this one. Okay, let's try this quickly. And then we end for today. This is question number 7 from the worksheet. Sorry, not the worksheet. It's 2016. November, paper 4-3, question 7. Okay, a box of 50 kg is at rest on a plane inclined at 10 degrees to the horizontal. Find an inequality for the coefficient of friction between the box and the plane. Okay, but is there a specific part of this question that you're confused in? Part 2. Okay, all right. So it's an inclined plane like this. This angle of the plane is 10 degrees. There is a box of 50 kg on this inclined plane. That means the weight of the block is going to be 500 Newton. That acts vertically downwards. Find an inequality for the coefficient of friction between the box and the plane. Now, it says it's at rest. Now, remember, when the object is in equilibrium, what did we discuss about friction? Friction is supposed to be less than or equal to mu r. Friction is less than or equal to the maximum value. Okay, so F is less than or equal to mu r. That's what we can use here. Now, let's just represent all the forces acting on this block. We have weight of the object. We've got reaction. Reaction acts perpendicular to the surface. It's going to act in this direction. There's going to be friction. The component of weight is going to act here. So there's one component of weight acting here. This is going to be 500 sine of 10 because this angle is also 10 degrees. So that's 500 sine 10. And this one is going to be 500 cos 10. These are the two components of weight that we've got. Now, because of weight, the block will try to slide down. Friction is going to oppose that. Friction is going to act in this direction. Now, since it's equilibrium, opposite forces are supposed to be equal. Left force is supposed to be equal to the force acting toward the right side. That means 500 sine of 10. That should equal friction. And R should equal 500 into cos of 10. Now, friction turns out to be 500 sine 10, which is 86.824. And reaction turns out to be 500 into cos of 10, which is 492.4. 0.404. This is reaction. So we have the value of friction and reaction. Now we say, since the object is at rest, F is less than or equal to mu r. So 86.824, that should be less than or equal to mu into 492.404. And mu is greater than or equal to 86.824 divided by that. That's 0.176. Mu is supposed to be greater than or equal to this value. Okay, that's the first part. Does that make sense? The first part? Now, it says, in fact, the coefficient of friction between the box and the plane is 0.19. So now they've given you the coefficient of friction value. That is 0.19. A girl pushes the box with a force of 50 Newton. So now there's another force acting. I'm just going to copy this diagram here. These were the forces acting earlier. Now I'm just going to get rid of friction from there because we don't necessarily know the direction of friction now. So let's see what other forces we've got. A girl pushes the box with a force of 50 Newton, acting down a line of greater slope of the plane for a distance of 5 meters. Now, she's pushing the block downwards. So there's a force acting in this direction that has a magnitude of 50 Newton. And if she pushes the block for a distance of 5 meters, she then stops pushing. Use an energy method to find the speed of the box when it has traveled a further 5 meters. Okay. So she pushes the block for 5 meters initially, and then she pushes it for 5 meters. Then the box travels 5 meters more after that. We need to find the speed of the box. That's what we're looking for when it has traveled a further 5 meters. Okay, now how do we think about this? These were the forces acting. Now we have another force acting. That's the driving force. We've got weight as well. These are the components. Now, let me just draw another diagram here just to try to understand the distances. I'm just going to draw another copy of that. Let's say this is 10 degrees. What's happening is, this was the block, let's say somewhere. It travels a distance of 5 meters and reaches this point. And it travels another 5 meters after that and reaches this point. Let's call these points something to be able to easily refer to them. We could call this point X. We could call the point that it started from, let's call that X. Then this point Y, until the girl is pushing it. And then the final point Z. These are the 3 points that we've got. Now we need to use an energy method to find the speed of the box. Now, what energy method? There are only 2 methods that we have discussed in energy. One was conservation of energy, and the other was that work energy principle. Can we use conservation of energy here? We can't. Conservation of energy is used when there's no external force. In this case, we have a driving force, and we also have resistance, the friction that we've got, right? So both of those things are there. So we will be using the work energy principle, okay? Now, let's see what information we have for that. What information we have for the work energy principle. In the right diagram, we've got friction as well now. Friction still acts up the plane. Do we know the value of friction? We can figure that out because the perpendicular forces are still the same. Reaction is supposed to be equal to 500 cos 10. So we can say the value of reaction is 500 cos of 10. And that can help us figure out the maximum value of friction. Because when the object is moving, the value of friction is going to be at its maximum value. F equals mu r. What's the value of mu? Mu, they told us, is 0.19. And the value of r is 500 cos of 10. What we can do is we can find the value of friction using this. Let's see what that turns out to be. 0.19 into 500 into cos of 10, that's giving me 93.557 Newton. This is the value of friction. Okay. Now remember the work energy principle. What did it say? Work done by driving force, that equals change in kinetic energy plus the change in potential energy plus work done against resistance. So now we've got pretty much everything that we need. For change in potential energy, we would also need the vertical distance, right? We want the vertical height, the change in vertical height for change in potential energy. For that, we can use some trigonometry. Let's use this triangle for 5 meters. If this is 5, the angle is 10 degrees. Can we find this change in height? We can use trigonometry for this. We can say perpendicular over hypotenuse, that sine h over 5 equals sine of 10. So the value of h, the change in height here, five into sine of 10, that's giving me 0.86824. That's the change in height. Now let's apply the work energy principle from x to y first of all. Because x to y, we have a driving force as well. And then from y to z, we do not have that driving force. The girl is only pushing for the first 5 meters. So for the first 5 meters, we have to consider that driving force as well. And then afterwards, we don't have to consider that. So we'll have to break it down into 2 parts like this. Let's consider the xy part first of all. What happens from x to y? Work done by driving force, that equals change in kinetic energy plus the change in potential energy plus the work done against resistance. Now, what information do we have here? Work done by driving force, that was 50. Right? Into the distance traveled, that's 5. F into D, how do you find work done? Force into displacement. Driving force is 50. Work done by driving force, 50 into the displacement, that's 5 meters. That's the work done by driving force. Change in kinetic energy. Change in kinetic energy. Now, the object started from rest. It was at rest earlier, right? So initial kinetic energy was 0. What about the final kinetic energy at the point y? Do we know that? We don't. We don't know what happens after 5 meters. So we can say it's half into m. What was the mass of the object? Mass of the object was 50 into v squared minus u squared. U was 0. This is the change in kinetic energy. Plus the change in potential energy. What's the change in potential energy? mgh, m is 50 into g, that's 10. Change in height, remember the height is decreasing, so we should consider negative value here, minus 0.86824. The change in potential energy is going to be negative. And then we have to find the work done against resistance. What would that be? We've got the value of resistance, the value of friction now. That's 93.557. Multiply that with displacement, that is 5. And that is going to give you the value of V here. Let's see what that turns out to be. So you can find the value of V here. Can you do this calculation for me? 250 plus 500 into 0.86824 minus 93.557 into 5 into 2 divided by 50. Square root of that. I'm getting 2.941666. So you can say 167. Is that correct? Is that what you're getting? Can somebody confirm this calculation? Okay, so that's the velocity at y. Okay, so we have found the velocity at y, the speed at y. Now, let's see what happens in the next part of the journey from y to z. So now we have the next 5 meters. We have to find the speed of the box after the next 5 meters. So now we again apply the work energy principle, do exactly the same thing as before. I'm just going to copy this. Work done by driving force, that equals change in kinetic energy plus the change in potential energy plus work done against resistance. Now for the next 5 meters, she is not applying any force. So work done by driving force is 0. Change in kinetic energy. Now we again do not know the final velocity, but we know the initial velocity is now changed to 2.94167 squared. That's the change in kinetic energy. Plus change in potential energy, that's still the same. Right? Because the distance traveled on the plane is still 5 meters. So the change in vertical height is still the same. Work done against resistance is also still the same because we're still traveling 5 meters. Everything else remains the same. And now you can find the value of v again. This is going to give you the velocity at z, and that's what we're looking for. You can see what this turns out to be now. 500 into 0.86824 minus 93.557 into 5 multiplied by 2 divided by 50 plus 2.94167 squared, and then square root of that. And that's giving me 2.703. That's the final velocity that we're getting at z, and that's what we were looking for, 2.70. Is that okay? So we had to apply the work energy principle twice here. Okay. All right, now it says the box then comes to a plane inclined at 20 degrees below the horizontal. The box moves down a line of greatest slope of this plane. The coefficient of friction is still 0.19 and the girl is not pushing the box. Find the acceleration of the box. Okay, so now you have a plane that's inclined at 20 degrees below the horizontal. So now it's a plane that looks something like this. 20 degrees below the horizontal. Okay. Coefficient of friction is still 0.19. Find the acceleration of the block. So now the block is like this. What are the forces acting on the block? We've got weight of the block, that is 500 Newton. We've got reaction. We have friction. Friction is going to oppose the motion. That's in this direction. If this angle is 20, what about this angle? This angle is also going to be 20. And that means this is also 20. This component is 500 cos 20, and the other component is 500 sine 20. These are all the forces acting. Are we missing any force? No. Okay. So now we need to find the acceleration of the block. There's no acceleration perpendicular to surface. So these forces are always equal. R equals 500 into cos of 20. And that gives you the value of R. Let's see what that turns out to be. 500 into cos of 20. And that's giving me 469.8 Newton. That's R. Along the surface, there is acceleration. Since the block is trying to move down, what's the forward force? So we use resultant force equals mass into acceleration. Forward force is 500 into sine of 20 minus the backward force, which is friction. That equals mass, which is 50 into acceleration. What's the friction? When the object is moving, friction is supposed to be at its maximum value. That means mu r. Mu was 0.19 into R, that's 469.8. That equals 50 times A. And that is going to give you the value of A. You can see what that turns out to be. 500 into sine of 20 minus 0.19 into 469.8 divided by 50. And that's giving me 1.63496. If we were to round it off, we would say this is 1.63 meters per second squared. That's the acceleration. Okay? Make sense? Okay, good. So that's it for today. If you have any other problems, you can now post them on the WhatsApp group and we could discuss them there. I also have the past paper session starting from 13th of April. If any of you is interested, you can have a look at the WhatsApp group for the registration link. You can register there. The discount for you guys is going to be valid throughout. Otherwise, the discount has ended on 5th of April. But those of you who are taking the crash course, you can register anytime. If you're interested, then you can get that discount. Okay, so you can find more information about that in the link. The details are mentioned there. Okay, so that's it for today. I will see you later at another time, inshallah.